The main motivation of this work is to distinguish counterfeit from legitimate documents. This has very specific requirements. We want these processes to have high throughput, therefore avoiding backlogs at specific locations like border crossings. We also need these processes to have high sensitivity and selectivity, because false positives can cause distress and delays, and false negative could create safety breaches. Lastly, we also want these processes to be non-destructive in terms of the document itself, especially in the case of false positives, but not limited to. The latest generation of identification documents, namely national passports and identification cards, they are more sophisticated. They're made of multiple materials which are layered together and fused together. But as sophistication increases, so does the level of sophistication from forgeries. Subsurface security elements are harder to fake. And this leads us to our research question. What can we do about this? Are there any techniques in the optics field which could help us? Introducing optical coherence tomography, with OCT for short. People are familiar with it in terms of biomedical applications, but effectively, for this application, it is absolutely perfect. Documents are made of semi-transparent layers, and these security markings often match the lateral scan ranges of OCT systems, up to tens of millimeters. The technique is inherently non-destructive, non-contact, and relatively rapid if specific areas are targeted. With our patented master-slave OCT processing technique, we allow direct en-face views to be rendered, making the system very intuitive to use. We can also correct for curvature. In this communication, we refer to a preliminary study that was published in Science and Justice using a specimen passport and a national ID card. Our work ahead involves mostly integration. How can we take the technology from our labs into a device that is intuitive and it's integrated with the workflows employed by the document examiners? So watch this space. We also would like to acknowledge our funding sources and the support from Foster and Freeman, which was invaluable in this project.